In this video, we are going to go over the properties of gases. We're going to focus on substances that are gases at room temperature. Gases in breath, such as oxygen and carbon dioxide. Common combustion gases are methane and propane, and anesthetics that cross the blood-brain barrier. Other examples of gases are helium, ozone, carbon dioxide, and water vapor. And remember, a gas is a state of matter with no fixed volume or shape. The kinetic molecular theory or kinetic molecular view describes the behavior of gases at the molecular level. So gases, atoms, and molecules are in constant motion, moving at high speeds. The greater their speed, the greater their kinetic energy, and the higher the temperature of the gas. Gases, atoms, or molecules move in straight lines, but in random directions, collide with walls of their containers, and fill the entire volume of their container. Gaseous atoms or molecules are far apart from one another and therefore have negligible intermolecular forces of attraction. Gases are compressible, giving them unique properties that are different from solids and liquids, and pressure is therefore an important variable in defining a gas. Pressure, or P, is defined as the force per unit area. Pressure of a gas is the result of the force of the atoms or molecules colliding with the walls of their container. Because remember, the molecules of gas are in constant motion. They're constantly moving until they hit something. So they're constantly hitting the sides of whichever container they're in. Force increases as the number of collisions with the container increase and the energy of the collisions increase. There are different units of pressure. Atmosphere, or ATM, is the most common unit of pressure. In medicine, millimeters of mercury, or mmHg, is commonly used. A Pascal, or PA, is the SI unit of pressure. 1 atmosphere is equal to 760 millimeters of mercury, or 760 torr. 1 atmosphere is also equal to 14.7 psi, or pounds per square inch, or 101,325 pascals. Atmospheric pressure. So air is a mixture of about 78% nitrogen, 21% oxygen, and then small amounts of water vapor, carbon dioxide, and argon. And atmospheric pressure is the pressure that the air molecules, so that these air molecules exert on Earth due to gravity. At sea level, atmospheric pressure is 1 atmosphere. A barometer is a device that measures atmospheric pressure. So the air pressure forces mercury into the empty tube so that there's no air in the tube. And then at sea level, the height of the mercury in the tube is 760 millimeters mercury, or 760 torr. As it changes wherever you go, the height of the mercury is going to change, and that's how you can tell what the atmospheric pressure is. That's how by reading the barometer is how the level of mercury changes based on the pressure within that tube. At higher altitudes, we have lower atmospheric pressure, because there are fewer gas molecules exerting pressure. In Denver, Colorado, the atmospheric pressure is 0.83 atmospheres, whereas sea level, it's at 1 atmosphere. Mountain climbers find it increasingly difficult to breathe because of the less oxygen molecules in the air whenever they inhale with every breath over time. But over time, the body compensates for this reduced amount of oxygen if they are avid mountain climbers at high altitudes by producing more red blood cells. So in summary, the kinetic molecular view of a gas describes the atoms and molecules moving at high speed in straight lines, random directions, colliding with the walls in their container, and exhibiting negligible intermolecular forces of attraction. Pressure is defined as force per unit area. Common units of pressure include atmospheres, millimeter mercury, pounds per square inch, or psi, and pascals.